The assembly would likely fall under Article 422 of the National Electrical Code, which covers industrial heating equipment. All exposed non-current carrying metal parts of the assembly must be grounded. The grounding conductor must be sized in accordance with Table 250.122 of the National Electrical Code, which for a circuit rated 0.6 amps would require a minimum of a number 14 American wire gauge conductor. Listed screw-on ground lugs that are designed for aluminum surfaces are available in compact sizes. These can be installed using a stainless steel screwer and lock washer. Listed grounding clips that wrap around the frame of the assembly and provide a secure electrical connection are also available in compact sizes. Listed pre-assembled grounding assemblies that include a ground screw, washer, and ground lug can simplify the installation process. Ensure that the grounding method chosen provides a low resistance path to ground. Take into account the environmental factors present in the production plant, such as corrosion or extreme temperatures, and select a grounding method that is suitable. It is preferable to use listed parts for grounding purposes. This ensures that the components have been tested to meet specific safety standards. Based on the information provided, I would recommend using a number 10 stainless steel screw, stainless steel external lock washer, and a listed screw-on ground lug designed for aluminum surfaces. This method is compact, provides a secure electrical connection, and uses listed components. The National Electrical Code, or NEC, is a regionally adoptable standard for the safe installation of electrical wiring and equipment in the United States. It is part of the National Fire Code series published by the National Fire Protection Association, or NFPA. While it is not itself a law, the NEC is commonly adopted by states and municipalities in an effort to standardize their enforcement of safe electrical practices. In some cases, the NEC is amended with local requirements. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is updated every 3 years to reflect changes in technology and industry best practices. Article 422 of the NEC specifically addresses appliances. This article provides requirements for the installation and use of appliances, including those used for heating. It covers topics such as disconnecting means, overcurrent protection, and grounding. Grounding is a critical safety measure in electrical systems. It provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse and to energize the circuit. This prevents electrical shock hazards and reduces the risk of fire. There are two main types of grounding: equipment grounding and system grounding. Equipment grounding connects the non-current carrying metal parts of electrical equipment to ground. System grounding connects one of the current carrying conductors of the electrical system to ground. For the heating assembly in question, equipment grounding is the primary concern. All exposed non-current carrying metal parts of the assembly must be grounded. This includes the metal frame, enclosure, and any other metal parts that could become energized in the event of a fault. The grounding conductor must be sized in accordance with Table 250.122 of the NEC. This table specifies the minimum size of the grounding conductor based on the rating of the overcurrent protective device protecting the circuit. For a circuit rated 0.6 amps, a minimum of a number 14 American wire gauge conductor is required. Several compact grounding options are available for use with the heating assembly. These include screw-on ground lugs, grounding clips, and pre-assembled grounding assemblies. Screw-on ground lugs are designed to be attached to a metal surface using the screw. They provide a secure electrical connection for the grounding conductor. Grounding clips are designed to clip onto the frame of the assembly. They provide a convenient and easy way to ground the assembly. Pre-assembled grounding assemblies include a ground screw, washer, and ground lug. They simplify the installation process and ensure that all of the necessary components are included. When selecting a grounding method, it is important to ensure that it provides a low resistance path to ground. The lower the resistance, the more effective the grounding system will be. It is also important to consider the environmental factors present in the production plant. If the plant is subject to corrosion or extreme temperatures, a grounding method that is resistant to these conditions should be selected. It is preferable to use listed parts for grounding purposes. Listed parts have been tested to meet specific safety standards. This provides assurance that the components will perform as intended and will not pose a safety hazard. In the case of the heating assembly, I would recommend using a number 10 stainless steel screw, stainless steel external lock washer, and a listed screw-on ground lug designed for aluminum surfaces. This method is compact, provides a secure electrical connection, and uses listed components. Stainless steel is a good choice for the screw and lock washer because it is resistant to corrosion. The external lock washer helps to prevent the screw from loosening over time. The screw-on ground lug should be designed for use with aluminum surfaces. This will ensure that the lug makes a good electrical connection with the aluminum frame of the assembly. When installing the grounding lug, be sure to clean the aluminum surface to remove any dirt, grease, or corrosion. This will help to ensure a good electrical connection. Also, be sure to tighten the screw securely. The grounding conductor should be connected to the grounding lug using a crimp-on connector. The connector should be sized appropriately for the size of the grounding conductor. Once the grounding conductor is connected, it should be routed back to the electrical panel and connected to the grounding bus. The grounding bus is a metal bar that is connected to the earth. This provides a path for fault current to return to the source. Grounding is an essential safety measure that should be taken seriously. By properly grounding the heating assembly, you can help to prevent electrical shock hazards and reduce the risk of fire. The size of the grounding wire is determined by NEC Table 250.122, as previously stated. This table correlates the size of the overcurrent protection device such as a breaker or fuse to the minimum size of the grounding wire. For example, for a 15 or 20 amp circuit, a number 12 American wire gauge copper wire is required for the equipment grounding conductor. For a 30 amp circuit, a number 10 American wire gauge copper wire is required. For a 60 amp circuit, a number 8 American wire gauge copper wire is required. For a 100 amp circuit, a number 6 American wire gauge copper wire is required. And for a 200 amp circuit, a number 3 American wire gauge copper wire is required. There are also requirements for the type of grounding wire that can be used. The NEC specifies that the grounding wire must be made of copper or aluminum and must be insulated. The insulation must be green or green with a yellow stripe. The grounding wire must also be protected from physical damage. This can be accomplished by running the grounding wire in conduit or by using a cable with a metal jacket. In addition to the equipment grounding conductor, there is also a requirement for a grounding electrode conductor. The grounding electrode conductor connects the grounding electrode to the grounding bus in the electrical panel. The grounding electrode is typically a metal rod or plate that is buried in the ground. The size of the grounding electrode conductor is determined by NEC Table 250.66. This table correlates the size of the service entrance conductors to the minimum size of the grounding electrode conductor. For example, for service entrance conductors that are number 2 American wire gauge copper or number 1/0 American wire gauge aluminum, and number 8 American wire gauge copper wire is required for the grounding electrode conductor. For service entrance conductors that are number 1/0 American wire gauge copper or number 3/0 American wire gauge aluminum, and number 6 American wire gauge copper wire is required for the grounding electrode conductor. The grounding electrode conductor must be connected to the grounding electrode using a listed connector. The connector must be suitable for the type of grounding electrode being used. Grounding is a complex topic, and it is important to consult the NEC and a qualified electrician to ensure that the electrical system is properly grounded. In addition to the specific requirements for grounding heating equipment, there are also general requirements for grounding all electrical equipment. These requirements are found in Article 250 of the NEC. Article 250 covers topics such as grounding methods, grounding conductors, and grounding electrodes. It is important to be familiar with Article 250 in order to ensure that all electrical equipment is properly grounded. One of the most important requirements of Article 250 is that all exposed non-current carrying metal parts of electrical equipment must be grounded. This includes the metal frame, enclosure, and any other metal parts that could become energized in the event of a fault. The purpose of this requirement is to prevent electrical shock hazards. If a metal part of electrical equipment is not grounded, it could become energized if there is a fault in the electrical system. If a person then touches the energized metal part, they could receive an electric shock. By grounding the metal part, the fault current will flow to ground, which will trip the circuit breaker or fuse and energize the circuit. This will prevent the person from receiving an electric shock. There are several different methods that can be used to ground electrical equipment. One common method is to use a grounding wire. The grounding wire is connected to the metal part of the equipment and then to the grounding bus in the electrical panel. Another method is to use a metal conduit. The metal conduit provides a path for fault current to flow to ground. The NEC also specifies requirements for the type of grounding electrode that can be used. The grounding electrode is typically a metal rod or plate that is buried in the ground. The grounding electrode must be sized and installed in accordance with the NEC. Grounding is a critical safety measure that should be taken seriously. By properly grounding electrical equipment, it is possible to prevent electrical shock hazards and reduce the risk of fire. Always consult the NEC and a qualified electrician to ensure that the electrical system is properly grounded. When working with electrical equipment, it is important to take precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear rubber gloves. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working on electrical equipment, call a qualified electrician. Electricity is dangerous, and it is important to take precautions to protect yourself from electrical shock. Ensure the equipment grounding conductor is properly connected from the heating element back to the electrical panel. This wire provides the low impedance path for fault current to flow back to the source, tripping the overcurrent device. Verify that all connections are tight and corrosion-free. Loose or corroded connections can increase resistance and impede the flow of fault current. Perform regular inspections of the grounding system to ensure that it is in good condition. Look for any signs of damage or corrosion. Test the grounding system using a ground impedance tester to verify that it is providing a low impedance path to ground. Keep records of all inspections and tests. Proper grounding is crucial for electrical safety and preventing electrical shock hazards. Always adhere to the NEC guidelines and consult with a qualified electrician to ensure that your electrical system is properly grounded. Remember that electrical work can be dangerous. If you are not comfortable performing the work yourself, hire a qualified electrician.